Thank you. I will give you a bit of background because I think it's important to set this in context. It is a technical issue, of course, but we need to have some kind of shared vision. And I like the idea of green infrastructure being an ecosystem approach. And I also like the idea that green infrastructure solves a lot of these problems that we have in cities, which cost us billions. So if we can bring more soil, vegetation, and water into the city, then we solve a lot of these problems, and it pays for itself. We've also, of course, got this problem of climate change, which is still being ignored by too many people, and that means that we have more drought and more extreme weather, heavier rainfall, and that means that we need to really think about how our underground city will help us to cope with that. And of course, the other really helpful concept is this idea of ecosystem services. So these are the benefits that we get from nature free of charge, which are, if you like, a side effect of bringing more soil and vegetation and water into the city. But it's a helpful language, and there's a lot of academic research in ecosystem services if you're interested in the detail of that. And the other really important concept is multifunctionality. So we need to make sure that all the interventions that we have work together to bring us the whole range of ecosystem services. So I want to now go into this idea of the water-sensitive city. So the water-sensitive city and water-sensitive urban design is an idea that's come out of Australia, which looks at the water cycle in the city. So it's not just about drainage, which of course is very important, but also about reducing the amount of water that we consume, which is extracted from the wider environment. So it's looking at reducing the consumption of potable water, it's about recycling water, and it's about sustainable drainage as well. So I'm just going to look at a few important concepts here. So in the wider environment, you'll find that a lot of the rain that lands infiltrates, and that's typically about half of the rain that lands on the city. And of course, some of it's transpired as well, so that's very important. Not what we're talking about today, but evapotranspiration is very important. And in the greenfield environment, a relatively small amount of that water runs off. But in the town, because of the impermeable surfaces, the sealed surfaces, you'll find that the infiltration rates are much reduced, and evapotranspiration is reduced, and runoff is increased. And that runoff is a real problem because it means that water is polluted, so it's polluting the downstream, the water courses, but also it's sending water rapidly downstream through pipes and water courses to cause flooding. So we need to rediscover our underground in order to increase that infiltration rate. And another way of looking at it is to go from a linear process to a more circular process. And yet another way of looking at this, business as usual, means that we have all these sealed surfaces. We've got rid of too much of our soil. We've sealed things off. We need to mimic nature. Of course, if we mimic nature exactly, we don't have a town. So what that means is that we're de-paving, and where rivers have been put into pipes, we're bringing them to the surface. The Americans call that daylighting rivers. We're bringing in green roofs, we're harvesting rainwater. But today, a lot of it is about de-paving and the quality of that soil that is exposed. So just very rapidly, before we look underground, we'll bear in mind, of course, that we can put soil on buildings and we can hold a lot of rainfall on buildings. So this is a London Underground train shed, which causes flooding. And so London Underground wanted to use green roofs to hold a certain amount of rainfall. And so they've been measuring that with the University of East London. By the way, it's work that's been done for more than 30 years in Germany, but we, in England, people are determined to repeat that research to check it. And of course, we can intercept downpipes, very simple. And we, as I said before, we can daylight streams, or if they've been canalized, you know, that's not satisfactory. We can do this. This is in southeast London. So, okay, underground, people will often say, well, if we do depave, then we've still got a problem. It's crowded underground, and people will say, well, actually, it's too difficult. But remember that plants and vegetation and drainage is actually, for the most part, about a very shallow part of the underground. So there's something we can do there. And you'll often hear as well that in places where the geology is impermeable, so for instance, in London, there's a lot of clay, people will often argue, well, there's nothing we can do because it's impermeable. But of course, remember that the natural clay is not the only material. There's a lot of made ground, and we can replace soils with free draining soils if we wish. So there's a lot that we can do. Now, trees suffer. So we tend to put a small tree in a small pit, and we hope that the tree finds water. And yes, trees do find water. They usually find it in a sewer. So whenever you dig up a sewer, you'll find tree roots force their way into the sewer because the underground environment is so harsh. But our colleagues in places in Germany, and this is in Sweden, they will refurbish the soil. So when they're refurbishing a street, they will dig out, they will vacuum the existing soil away, leaving the tree roots, and they will dig out the ground and they will replace it in Sweden with a stony material, and they'll wash a soil which is suitable for the trees between those layers. Now, these structural soils can take the weight of paving and vehicles. So you have an option. You've created a large permeable void under the pavement. The surfaces are nicely wrapped up in whatever protective material is required. And so that is a sustainable drainage system, if you like, which can store a lot of water. It can infiltrate and clean water. But as I say, you can pave over this. Or you can leave it open and top it up with soil as a planter. So this is what they do in Sweden. So you can have a tree that's been stressed, and then when you've refurbished with these technical soils, the tree's recovered within a year. It's recovered. You're reducing flood risk. And so this is something that can easily be done. It's not being done in the UK routinely, but it's something that we need to learn. And of course, there are other ways of doing this. So our American colleagues have these suspended pavements where they're using plastic boxes and free draining yet water absorbent soils, which can take the weight of paving and vehicles, but they give the space for the tree roots to spread. And there are people here supplying these products if you want to know more about the detail. And so the tree is much happier there. It's not seeking to steal water from the sewer. Of course, we can never guarantee that a tree won't do that, but we can make its life underground much happier. Another thing we can do when we depave, we can excavate the soil and replace it with a mixture of sand and composted material as a rain garden. And what's interesting about this kind of intervention is that money that, for instance, might be earmarked for something like traffic calming can be used for greening. So we're traffic calming, we're greening, we're increasing the amount of impermeable material to reduce flood risk. And we can do a lot of simple things. We can make cuts in curbs, we can lower beds, we can excavate soil and replace it. So a lot of these are simple principles about getting the levels right. So raised beds don't really work because they're not receiving runoff. But lowering beds, very simple changes. Again, this is an urban swale where it's a lowered bed. So even in a very urban area, we can do something with surface flood waters. And of course, the trees will grow more quickly. and a larger tree is providing us more ecosystem services, shade, cooling, intercepting air pollution. And you know, a lot of this can be a whole swarm of very small interventions all over the place, which on their own may not amount to very much, but collectively will start to transform the city. So instead of having a downpipe issuing into a block drain, we can issue into a rain garden. And of course, we unblock the drain so that when the rain garden fills, it can overflow into that. So I hope I've given you a good introduction to some of the issues here.